Hello, 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 ladies and gentlemen, and welcome back to question number 5 on the 2017 Euclid paper. Dan was born in a year between 1300 and 1400. Steve was born in a year between 1400 and 1500. Each was born on April 6th in a year that is a perfect square. Okay, well, there's only so many perfect squares in these ranges. Each lived for 110 years. Okay. In what year, while they were both alive, were their ages both perfect squares on April 7th? Okay. Okay, so we need the year, but we know they were born on perfect squares. So we could say something to the effect of, we say, let Dan be born in year A squared, and Steve in year C squared. And then if Dan is B squared, when Steve is D squared, we have A squared plus B squared equals C squared plus D squared, and that total should be the year, because it's when they were born plus their age. So that should be the year that we're looking for. So we want a number, a year number, that is the sum of two different squares. Now we have some restraints here, because obviously if we just had this one equation, there'd be lots of answers. But we know when Dan was born, so A squared has to be between 1300 and 1400. Steve was born between 1400 and 1500, so that gives us a range of values for C squared. We know both of them are have to be less than or equal to 110 for their ages. So both B squared and D squared are less than or equal to 110. And I suspect that will be enough information to narrow things down. Okay. So we know for a fact, so 1300, I just wrote 1300 less than or equal to A squared. It's kind of vague when they say between. So I'm gonna say it's less than 1400. Actually, it's probably less than for both of them. So C squared, 1500. So it's genuine. It's strictly between. The endpoints are not included. So we also have 0 must be less than or, well, it's April 7th. So actually no, I suppose it could be when there's 0, but I very much doubt that that's the case. So B squared and D squared must both be less than 110. So that gives us a particular range of values. B and D must both be less than 10, because the next perfect square would be 11 squared, which is 121, which is beyond their range. Now, A squared. So what could A squared be? Square root of 1300 is about 36 point something. So 36 is less than A, and then the square root of 1400. Just square rooting all sides of the inequality. So A has got to be more than 36, but less than or equal to 37. That tells me pretty quickly A has got to be 37. And C is also in this range, or also has a range. So less than or equal to 38. So C is going to be 38. There's nothing else we can do here. So now we've got 37 squared plus B squared is equal to 38 squared plus D squared. Well, we could rearrange and say, well, what's B squared minus D squared? It's 38 squared minus 37 squared, which is just going to be 37 plus 38, which is just going to be 75. And look at that, I've got a difference of squares over here. Or we could probably just start listing out. Actually, yeah, I think it might be a little easier to just sort of say, well, D could be 1, 2, 3, 4, 5. Probably won't be beyond 6. And so then what's D squared? And then D squared plus 75, is that something I recognize as a perfect square? 9, 16, 25. Oh, 25, and then that would be 100. That's perfectly fine. 16 plus 75 is 91. That's no good. Plus 4 is 79, 76, 84. All of these are no good. And that would be 111. So it's got to be D is 5, B is 10. So what does that actually then tell us? Well, the year that we want is 37 squared plus 100 squared, or 10 squared. And that's 37 squared plus 100, and we get a year of 1469. Okay, and we could double check 38 squared plus 5 squared is also going to be 1469. So that's the year, and that's what we were asked for. Okay, so I'll flip the page because we've got B part left to do, and B part we actually have to write things up. Determine all values of k for which the points 1, 2, 11, 2, and k6 form a right-angled triangle. Okay. So let's just plot these points kind of quickly. So k is at 6, so we'll say, C, k6 sort of looks like up here. We've got 1, 2, and I think it was 11, 2? Or was it 2, 11? I think it was 11, 2. Yeah. So there's our C point. We can move C all about, but C is sort of stuck on this line right here. Okay. So we get from A to B, and we have some options because we just need it to be a right angle triangle. They just said that this is right angled, not where the right angle is. So we have some cases. Is the right angle over here at A? Is the right angle here at B? Or is the right angle here at C? Okay. And we can get different pictures. So if it was right angled at A, it would have to look something like this. If it was a right angle at B, it would get sort of the opposite. It would have to look a little something like this. And now, for the right angle at C, it would be sort of something like this. But we could also have it up here. So there's probably a couple. I think just 2, but I'm open to the possibility of more. But I think there's different cases. So we have a right angle at A case. And so, therefore, K, how can we get angles? I mean, I would say it's clear that C has to lie directly above A, but so let's say since AB is parallel to the x-axis, then AC is parallel to the y-axis. So K is equal to 1. If the right angle is at B. You know what? I suppose we could say, this is 10 here, and we could, in terms of K, get CB and CA, and then use Pythagoras. That's certainly a possibility. Anyways, right angle at B, same sort of reasoning. Since AB is parallel to the x-axis, then BC is parallel to the y-axis. So K is going to have to lie directly above. K will be 11. And then there are our other options. Okay, now our final case, right angle at C. So then AB squared is equal to AC squared plus CB squared. And I suppose we could have done this, but you would have had AB squared plus AC squared is CB squared, depending on where the hypotenuse would be. That would be, if CB is the hypotenuse, then the right angle is at A. So this is 10 squared is equal to, now how do we get the distance squared for A? Well, drop a perpendicular down here. This height here is 4. This distance is k minus 1. This is 11 minus k here. So AC squared is k minus 1 squared plus 4 squared. CB squared is 4 squared plus 11 minus k squared. And we can expand that out. And we can start collecting things. This is 100, so we can bring the 100 over to the other side, drop this down to a 21. We'll get 2k squared. 21 plus 1 is 22, plus 32 is 54. So we'll get 0 is 2k squared. I think it's minus 24k plus 54. I'll just go back and double check that. 2k squared minus 2k minus 22k, that's 24. 1, that's 17. 27 plus 6 is 33. 53, 54. Okay. So we'll go back. And so 0 is k squared minus 12k plus 27. I can factor that. K minus 9. K minus 3. So k is 3 or 9 in this case. And those are the only 3 cases. Either your right angle is at A, at C, or at B. Okay. So we might sum up. So k equals 1, 3, 9, or 11 will make triangle ABC a right triangle. Okay. Not bad at all. Let's flip the page in celebration of being halfway done the contest, and I will see you guys in the next video for question number 6. Until then, have a wonderful day.